All right, so I talked about in the last video about how you should start in the middle of your list of potential zeros because there's going to be tricks to help you eliminate some of those from the list. Well, here's where those tricks come in. So first we need to identify what upper and lower bounds are, and then how can we use those. So I'll describe how upper and lower bounds behave in just a second, but let's just go through the rules. So let f of x be a polynomial with real coefficients, again, nothing imaginary, and a positive leading coefficient. Divide f of x by x minus c using synthetic division, which we can do. We know how to do that. If c is greater than 0 and each number in the last row is either positive or 0, then c is an upper bound for the real zeros of f. Okay, we'll explain that in a minute. If c is less than 0 and the numbers in the last row are alternating positive and negative, entries of 0 count as positive or negative, then c is a lower bound for the zeros of f. Okay, so we have these consequences, but we don't know really what that means until we know what an upper and lower bound is. So let me give you a sketch. Let's say we had a polynomial and it crossed through -4, -2, and 2. So it went something like this. Some sort of polynomial, and it did that. All right, so let's say from my list, I had some different possible zeros. You know, if I had 1, obviously, as a possible zero from my list. What if I had 3 or something like that, you know, or a -5? So what are you going to see when you do synthetic division with some of these other numbers? When we do synthetic division with 1, it's really not going to give us anything by looking at the results. But when we do 3, if we were to check 3 using synthetic division, we're going to find that 3 is an upper bound. And what that means is that there's no other spot above that where the function crosses the x-axis. So we only need to look below 3 for where it crosses. So that's what they mean by upper bound. There's nothing above that number where the function is going to cross the x-axis. Very similar on the other side. We could say that -5 is a lower bound because the function doesn't cross anywhere below -3, or excuse me, -5. So once you've established an upper and lower bound, you only have to look in between those cutoffs and to see where those zeros could possibly happen. So let's just do a verification problem, and then we'll try a couple. So it says verify that the following upper and lower bound for f of x equals blah, 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 blah. Upper is 4, and the lower is -1. Now the other thing to keep in mind is that the leading coefficient is positive. That was something else that needed to be in place. So it is positive, so we should be able to use our tests. So let's check 4 first. So x to the 4th power. So be careful. Don't forget any of those powers of x. So 1, we do have x cubed. So -4 would be next. We are missing x squared. So we need to keep track of that. We're missing x. So we got to keep track of that. And then we can put our constant. Let's see what happens. So we multiply to get 4, subtract to get 0, 0, 0, 0, 0, 0, 15. Now this one's not very interesting because it's not pretty in the fact that we have other numbers than 0, but let's verify the rule. So it says if C is greater than 0, which it is, C is 4, and each number in the last row is either positive or 0, then C is an upper bound for the real zeros. So we do have zeros in here, which we count as positive in this case. So everything's positive in this last row, so that's why 4 is an upper bound. So yes, 4 is an upper bound. All right, let's do the same thing, but let's check -1. So 1, -4, 0, 0, 15. Let's slide this up a little bit here. So we got a 1, -1, -5, +5, +5 when we add, -5, -5, +5, +20. Okay, so now let's go back to the rule. If C is less than 0, and it is, it's -1, and the numbers in the last row are alternatively positive and negative, entries of 0 count as positive or negative, then C is the lower bound for, or a lower bound for the zeros of F. So in this case, we can clearly see that they do alternate signs, positive, negative, positive, negative, positive. Now, remember, 0 can be substituted in and it would still satisfy. So if this had been 0, we can count 0 as negative in this case. So it would have been, still been a lower bound. So yeah, 0 is a funky one when we're doing synthetic division. But yes, -1 is I'm going to abbreviate, LB, lower bound, UB, upper bound. All right, so again, very nice way to help eliminate some values, but let's put it to use in our next example. So this one says to use the rational zero theorem, so P's and Q's, and the theorem on bounds, which we just saw, as aids in finding all real and imaginary roots of each equation. Again, roots, zeros, same thing. Don't think it's something different. All right. Well, let's do our P's and Q's. Now, in looking at our Q's, we can see that the leading coefficient is 1, so Q is 1. So P is going to be equal to P over Q in this case. So we just want factors of 10. So let's do plus or minus 1, plus or minus 2, 3. Whoops, not 3. 3 doesn't go into 10, silly. How about 5 and 10? So there's our only possible rational zeros. Now, remember how I said let's start in the middle of the list. So I would start with either the 2s or the 5s, doesn't matter. Let's try 5. See if we get an upper bound. So 1, -4, -7, +10. Well, son of a gun. We got a 0 in this case. Well, that kind of, breaks the problem down a lot faster for us. But let's just do a couple of other little checks here. Let's check 10 and see what would have happened. So 1, 10, 6, 60, 53, 530, 540. So again, all of these are greater than 0. So we know that 10 is an upper bound. Now, obviously there's nothing above 10 for us to check, but at least we know we wouldn't have had to go above 10 to see if there was another possible 0. Same thing on the lower end. If we would have checked something low, let's try -5. See if -5 is a lower bound. Oops, So when we multiply and add, well, based off of that, it doesn't look like, oh, actually, I made a boo-boo, didn't I? Negative 5 times that would have been a negative 190. So that does give us a lower bound. Be careful of those negatives, even me. So just be careful. So negative 190, so that does alternate signs. So we can say negative 5 is a lower bound. Oh, move my head out of the way. So they do alternate. So we do have that conclusion. So we wouldn't have had to check negative 10 as a possible 0 because negative 5 is a lower bound. But since we already have a 0, we're on the home stretch. Just like before, we can start to factor this down. And there is going to be our quotient function. So x squared plus x minus 2 equals 0. We can factor this one pretty quickly. Signs are going to be different in this case. Last sign is negative, so we know the signs are different. So plus and minus. And it's only factors of 2, so I think the 2 is going to have to go here, and the 1 will have to go there. And so they do want the roots, they do want the zeros, so let's just list them out. So x is 5, negative 2, and positive 1. All right. Let's try one more of these, and that will wrap up 2.5. So this video might be a little longer, but it'll be worth it. So, all right, this one's a little bit more interesting because we have x to the 4th power in this one. So, but the leading coefficient is 1 again. So remember, P will define our P over Q. So P will be P over Q, which is going to be factors of our constant. So 12. So 1, 2, 3, 4, 6, and 12. So there's our possible factors, our possible rational zeros. And so now let's check, see if we can get an upper and lower bound. So again, let's start in the middle of the list. So we can start with either 3 or 4, whichever one you want. Let's try the 3, I guess. I don't know. Probably be unlucky again and get a 0, but you never know. So we got a 1, negative 4, 7, negative 16, and 12. So let's see what we get. And son of a gun, we found a 0. So, but this one is a 4th degree polynomial. So even though we found a 0 and we could try to factor and things like that, well, you might not be able to factor it, or factoring is not your thing. So what do? Well, we can rewrite this using that 3, but keep in mind what's left over. So again, remainder, constant, x squared, x cubed. So this is going to be x cubed minus x squared plus 4x minus 4 equals 0. Well, again, yeah, we're going to have to break that down even more. So what do? Well, we can do our p's and q's again based off of this piece. But leading coefficient's 1, so all we care about are the p's. So which in this case is just going to be factors of 4. So plus or minus 1, plus or minus 2, plus or minus 4. So let's try 4. So again, we want to make sure we use the coefficients of our new quotient. So 1, -1, 4, and -4. So let's see what we get. Oops. Oops, there goes my lead. 3, 12, 16, 24, and 20. Well, we didn't find a 0, but we did conclude that 4 is an upper bound. So 4 is an upper bound is, but there wasn't anything above 4 to check, so unfortunately that's not going to help us much. Let's try a 2. Now remember, we can try negatives as well, so if you want, heck, let's try -2. Let's do something different. So we got a 1, a -2, -3, 6, 10, -20, -24. Well, it's not a 0, but it does alternate. So we also know that -2 is a lower bound. So we don't have to check -4 at least. Well, we skipped all over the 1s. Maybe 1 is the magic number. I don't know. One, 1, 0, 0, 4, 4, 0. Well, look at that. So 1 is a 0 for our polynomial. So now we can go back up, and where did it go? It's way up there. There it is. All right. So we already know that we have the x minus 3, and 1 was a 0, so that means we have to write it as a factor, so x minus 1, and then we have to write the rest of it. So what's the rest of it? Well, remainder, constant, x squared. So there's no x term. So x squared plus 4. So x squared plus 4. All right. So we got to break this down. How do we do that? Well, if you're not sure, because there's no x term, this is actually a nice problem to solve equal to 0. So let's do it this way. Let's set each of these factors equal to 0, and then we'll break them down. Whoops. So x squared plus 4 equals 0. So we know this is x equals 3. This is x equals 1. But this is going to become x squared equals -4 once we move the 4 over to the other side. How do we solve that? Square roots. And because we're taking the square root of both sides, we get plus or minus the square root of -4. And how do we write that now? Using our methods from 2.4, we know that that should be 2i. So there's our zeros. So, all right. And so that wraps up, and you can see that we have 4 zeros before we wrap up. There's 4 zeros, and x is to the 4th power, so we know that that's the way it should be. If it's to the 4th power, we should have 4 zeros, even if some of them are imaginary. So, something to keep in mind. But that wraps up 2.5. So, one more section in this unit, and we'll have it wrapped up. So, see you very soon.